Let's go.
Good evening, everyone. Good
Are we
evening,
live?
good evening. Yes, so we are live. Yes. Good evening, Sanjay Vitkar. Good evening, Rishabh. Good evening, everyone. Yeah, Dipindu as we started, it will be active now. Okay, hello, everyone. I welcome you all to the Data Science Essential Program, Day 4. Today, we are going with the NumPy and the Pandas. Are you guys with me or not? Just tell me in the comment section with a thumbs up or with a yes. I'm seeing your chat. Just reply me quick so we can proceed further. Are you all guys with me or not? Just make me a thumbs up. Yes, 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 yes. Good evening. Okay, so let me have a quick review of what we have studied yesterday. We talked about the list functions and the dictionary and the sets functions, how we can modify them. Today we are going with the NumPy, library in the Python, which keeps you specialized in the various functions through which you can modify or compute numerical computing. Before that, just mark your attendance, and if you have any queries, just put it in the comment section, or you can join our community group too. Uh, just mark your attendance for the day. It's in the comment section and in the description. Now I welcome Darshan sir to proceed for the session today. Good evening, sir.
Thank you very much, Jyotsna. Good evening, Jyotsna. Thank you very much. So,
Thank you, Sivarama. Sir, it's for you. We are teaching ultimate.
thank you very much. Honestly speaking, I am hearing this multiple number of times from a lot of learners, but every time I hear it from anyone, it actually motivates me a lot to give something more better than what it is. So it's kind of something very boring for me to listen that sir, your teaching is ultimate. But to be very honest, from the bottom of my heart, I really value each and every comment because ultimately that gives me a feedback, right? As I'm on the right track and whatever I'm teaching is clear to each and every learner. So yes, I do value all of that. Thank you very much.
Yes, sir, you are going well.
Perfect. So guys, let's get started. Today we have to get started with NumPy and Pandas. Uh, Not Pandas actually, NumPy and Matplotlib, and then Pandas and Seaborn. So that's how the clubbing is going to be. So we have today is Wednesday, Thursday, Friday. So today we have 2 hours, and then we have 1 hour 30 minutes and 1 hour 30 minutes. So total this is going to comprise for 3 hours, and this so total we have assigned 5 hours for understanding NumPy, Pandas, and Matplotlib and Seaborn. Yes, thank you very much, Sivarama. I totally value that. So now let's get ahead. We are starting with the data science modules, NumPy, Pandas. So starting with the very first one, NumPy. So first of all, I mean, even before I proceed, we need to understand what is exactly NumPy. Guys, whenever you talk of NumPy, first try to understand what is the full form of NumPy. Well, NumPy stands for numerical and PY stands for Python. So whenever you want to perform any kind of numerical operations on Python, then we go to NumPy. Now you may wonder and ask then, sir, why do we actually want NumPy then? I think the same could be done by our regular Python as well, right? Our Python has list, our Python has dictionary, our Python has tuple, it has sets, it has arrays as well. So why the hell do we require NumPy? Well, that is for just one reason. NumPy is fast. No, it's super fast. Super fast. It's almost 10 times faster than our regular Python. You know why? Reason for NumPy being much faster than our regular Python is NumPy also consists of all of the functions, and all of these functions are vectorized in nature. Oh, you know what? You have been studying so many programming languages. If you are from a technical background, and I'm sure that I know it. In fact, I'm very much sure that all of you, I mean, most of you have gone through C, C++, Java, and now on the verge of learning Python. So those who have gone through this really value the crust of the programming, the core programming language, right? Precisely C and C++. So now, friends, among all of this language, if you ask me how is Python, well, if you ask me to rate everything on a scale of 10, I would rate C as 9 on 10 and Python as 7 on 10, or maybe I can also say 6 on 10. You know why? Well, you may say that, sir, then Python is such a beautiful language. It's so much easy. Non-coders can study it as well. You are yourself teaching Python to so many students. You are teaching machine learning. So everywhere you are using Python. Then why are you complaining about Python? Well, that is because Python is a slow language. If you compare with C, C is comparatively, although it's a high level language, but this language is very near to the hardware of the computer. That is the reason today also for updating any of the transactions which require a milli to nanosecond accuracy, C++ programs are still preferred. Yes, C and C++, both of them are equally faster over here. So it's much advantageous. Point number one. Okay. Then Python is comparatively slow language. The only reason for Python being so popular over here is because it was endorsed by Google. Okay, that is the only reason it gained the popularity, and a lot of the functions are easily available. Point number one. So now, why NumPy? Because NumPy is equally fast as C, C++. Now you may ask why, right? If Python is slow and NumPy is also going to be coding in Python, then why? Because NumPy's function are vectorized in nature. What do you mean by vectorized? Well, the body of the function is written in C, C++ languages. So inherently, although you are calling a Python function, a call goes to C, C++ functions only, because the body is written in other language. So therefore I say, it's kind of a multi-programming environment that you are using without even realizing that you are doing the same thing. That is the power of vectorized functions, and therefore NumPy is considered to be much powerful than Python. So, well, if I say over here, NumPy versus just Python, and let's say NumPy versus Python speed. I mean, so how fast is NumPy and why? If I just go through any of the code available on the internet, what is going to happen over here is, if I take np.log, and yes, that could be one of the best way. Let's try to understand these things with respect to this. So, I say I did not even import math. Just a second. Import math, import NumPy as np. So I just wanted to calculate how much time does it take to calculate log of this. It is taking total 305 nanoseconds plus or minus these many nanoseconds, as you can see, right? If I do the same thing, okay, I'm calculating the same thing over here using the NumPy function. I'll just check it out, and well, NumPy has taken just 1.5 nanoseconds. So do you see over here how fast is NumPy compared to regular Python? This is 305 nanoseconds. Okay, and this is taking just 1.95 nanoseconds. One more example, I guess they have it over here. Uh, Comparing this, I just cut it off, and here it takes 315 nanoseconds for doing this exponential calculation. And if I talk of over here, 1.84 nanoseconds. I mean, where is 300 and where is 1.8? You call it as Zameen Asman ka difference hai. Yes, that's it. That's it. So therefore, we understand that yes, NumPy is very, very crisp. Okay. Amy, you're asking some interview questions. First of all, I think let us focus on understanding what is NumPy, and then we'll go and talk of interview questions if time persists at the end. So one thing is for sure that yes, NumPy is much much faster than all other programming languages. Okay. Similarly, okay, fine. I think I'll just get this link for you as well, so that whenever you study, you have it. So perfect. Here, adding a thing and sorted. Cool. Let's go ahead now. The thing is how to use NumPy. Well, you need to import NumPy as NP. Now you may say, so why as NP? You can consider this as kind of a de facto standard. Okay, it's not mandatory to import NumPy as NP, but if you open any research books, any reference books, any research papers, any other articles on the internet, any blogs, everywhere you will realize that people have given a abbreviation as NP. So when you work on a real life problem, see, what you do is you don't keep on typing the code every time. You copy it, right? We are living in the era where the information is available. How much ever we want have it, right? So there's absolute no harm in copying the information, not at all, but you should be able to mold it in the way you want to. Okay, so therefore I say that can I import NumPy as NP? Yes, because we want the same thing. Okay, so uh Vaishnav, don't take this codes too seriously. I was just trying to explain you that how fast is NumPy compared to all other normal Python functions. Okay, what is this doing? Well, Webo, this is just calculating the log of 10, and this is also calculating the log of 10. The only thing is this is a function of math and this is a function of NumPy. That's it. And these are the times using percent time it. It's like time it. So tell me, how much time did you take for executing this? If you don't write this, you will not get the time. That's it. That's the only difference. So everywhere you write percent time it is going to tell you how much time did it take for executing that particular line of code. Simple. Okay, Vaishnav, how much time did it take for executing that particular line of code? That is what is percent time it going to do. So now I like to see the version. So I say np dot version. If you want, you can put it in print as well. So this is the version of NumPy which I am using. Maybe if you have just installed the Anaconda Navigator, probably you may get the latest version. I don't know. I need to check what is the latest version right now. So I can also go to NumPy documentation and search for it. numpy.org. Yes, this is the latest version that we have, 1.20.0, and I am having 1.19.2. Well, it doesn't hamper my explanation a lot, or it neither hampers any of my operations. Okay, but this is the latest one. Now you may ask, sir, how to update your NumPy? Well, that's pretty simple. You have a lot of functions for doing it, but let's not get into all those things right now. Okay, so now let's get started with understanding what is exactly NumPy. As I told you, NumPy is used for performing numerical operations. Yes, it's used for performing numerical operations, and the main purpose of NumPy is to store the information in the form of numerical arrays. You remember we never talked of arrays in our normal Python, but In NumPy, we are going to use only and only arrays. For your simplicity, let me tell you that that arrays actually look like list only. For example, if I have to declare a NumPy array, you know how I declare? I can say over here that I want to declare a NumPy array using the function np.array. This function says whatever you want to store inside me, give it in the form of a list or a tuple. Whatever you give, it's fine. Usually, as I told you last time also, we prefer a list only. So I say the values are going to be 10 comma 20 comma 30. Let's say for simplicity, we get the answer over here as 10 20 30. Okay. Similarly, I can also give a tuple over here. That doesn't make any difference. If you observe, it is again stored in the form of a NumPy array. Well, if you want to check the type of it, please check. What is the type of this? Well, it is a n-dimensional array. So friends, here I would like to tell you that our NumPy session is going to break NumPy into two parts. One is called as ND array, another is called as U functions. Well, ND array stands for n dimensional arrays. ND array stands for n dimensional arrays, and U function stands for universal functions. Okay, so ND arrays are mainly going to deal with matrices or arrays. Precisely, I say they are n dimensional arrays, and U function are mainly used to deal with the broadcasting thing. Now, I will explain this in the second half, not right now. Right now, let us only talk of n dimensional arrays. Okay, so now getting started with n dimensional arrays. So someone may say, sir, can I store a numpy array in the form of a set or in the form of any other thing? Well, you try all those things. That's not a standard way of doing it. We usually have a habit of storing it in the form of an list. So you usually we pass a list almost every time. We pass a list over here, and this is how a numpy nd array gets created. As simple as that. Okay. If I say, let me have a ND array over here. So let the name of the array be this. Okay, 10, 20, 30. Now, after this, if I say, print for me ARR, just look at the different ways of looking at the problem. How does this thing work? Well, an array called as ARR is created at index location 0, you store 10. At index location 1, you store 20. At index location 2, you store 30. And there is forward indexing. Yes, it is very much similar to list as I told you. Friends, let me tell you, there is backward indexing as well. -1, -2, -3. It works. I will show you all that later. Right now, let's try to understand NumPy. So printing of array, no doubt it gives me this. Okay. Now if you print it using the print statement, it doesn't print it in this way, but that's fine. Still, it is a NumPy array only. I mean, if I look over here, what is type of ARR? You see, it is still a NumPy array. Okay. Now, if you look over here, there are two types of NumPy arrays. This is 1D NumPy array. Okay. So let me just make a note of it. So I say ND arrays are of two types. Okay, broadly classifying, they are of two types. The first one I call it as 1D arrays, and the second one I call it as 2D or more D arrays. Okay, 2D or more dimensional arrays, as simple as that. 3D, 4D, etc., etc., etc. So, sir, in case of NumPy, the unit is microsecond. So, how is it faster? In case of NumPy, the unit is microseconds. Oh, I didn't notice that. Well, just a second, just a second. Uh, Nanoseconds, microseconds. I didn't notice that. This nanosecond plus this nanosecond, and this is 1.72 microsecond. Even if you say that is going to be 1720 microsecond to 1720 nanoseconds. So if I see over here, it's 1720, it's much higher. I mean, what is wrong? If you look at this, uh, quite surprising. I also did not notice it. I straight away copied the code. Uh, Standard deviation of 7 runs. Let us visit this link. What does the user want to say? Hmm, let me paste and I need to check over here then. We did not read it, right? We just randomly copied it. So, okay, number is really in performance improvement for large blocks of data. The overhead of making memory blocks before pouring it. Okay. So if it's huge operation, then NumPy helps. For example, let me see over here NumPy versus NumPy range versus Python range speed. Hold on, I'll show it to you over here. X in range, and that was a very good observation, by the way. Even I didn't notice it. Okay, no problem. Then we will go with some other link. Ideally, I should have taken that perfectly. For x in range size x square, that is fine. So we are going to get this. It, out of the 10 loops, 136 millisecond per loop, and x range is going to give you 88.9 milliseconds, and numpy is going to give you just 1.16 seconds per loop, milliseconds and seconds, and numpy is 19.5 milliseconds. So in case numpy is 4 times faster than xrange. If you do it right, depending on your problem, numpy can be 4 to 5 times more faster. So yes, then what I will do is, I mean, I just randomly copied some code without even trusting that. So we will just have one more thing and we will discuss on this later, maybe tomorrow. Okay, although it is a guarantee that yes, numpy is much faster than normal python, but we will talk of this tomorrow, where I will come with a proper concrete example where there should be no confusion. Else what will happen is, if I now start implementing my own things which are coming in mind, it may happen that most of you may get disconnected with the session. I don't want you to go into that phase. So I will just say over here, let's discuss this tomorrow. Okay, what numpy versus Python speed. Okay, so let's go ahead. So we are talking over here of this particular thing. I have a numpy array. 10, 20, 30 is given. You have forward and backward indexing. And I was saying that yes, in numpy I can store 1D array or 2D array or 3D array or 4D array. Right now, please keep it very simple. I will be talking of only 1D and 2D array. I will talk of 3D array also, but after some time. Don't ask me questions. Okay, how to talk of 2D arrays over here. So I say over here, let us say if I want to declare a 2D array, then how to declare it? Well, you say 2D array is what? 2D array is an array of array. For example, let us say I want to create an array something like this. Probably I say 2D array is nothing but a matrix. So let's say I want to declare an array maybe like this: 1, 2, 3, 4, maybe 5 and 6. Okay, so I want to declare a 2D array something like this. So how many rows are there? This is row 0, row 1, row 2. This is column 0 and column 1. I want to declare a 2D array like this. Let me also call it as ARR. Anyways, they are in two different cells, so it doesn't make any sense. So I say, doesn't make any difference over here. So I say over here that how to declare a 2D array? Well, a 2D array is being declared as an array of array. That is, I say over here that every row is considered as an one-dimensional array. Every row is considered as an one-dimensional array, and all of this will be stored inside a bigger list. What does that mean? Well, overall, I say that I am going to declare an 2D array. So for 2D array, I write it like this. Now, what is there on the very first row? 1 and 2. Let's write it in square brackets. 1 comma 2. Then second row is 3 comma 4. So let me write over here 3 comma 4. Third row is 5 comma 6, and when I execute that, you can see it's exactly what I wanted, right? 1 2 3 4 5 6. Okay, so you are getting the things as expected over here. Now let us say I want to look at the data type of the elements inside this. So I say over here print arr dot data type. Okay, now let me tell you over here that d type is an attribute. Now you may say, what is an attribute? Well, attribute is nothing but the parameter of a function. It's not a function. Had it been a function, then I would have written d type followed by round brackets. I did not write that. So it is precisely int32 saying that hey, it is storing all the values of int32. So if I just change one of these values, maybe to 2.0, now, let's observe how the d type changes. If you change a single value as 2.0, it will convert everything to floating values. And you see over here, every value is stored like this. Now, students immediately ask me, sir, why is it stored as 1.2.3. Why not 1.0, 2.0? Well, I did not design NumPy. Whosoever designed it preferred this way of representation. Therefore, it is like this. Okay, so 1.2.3.4.5.6 and the data type becomes float 64 because one of the value has become over here changed. Makes sense? Okay, now if I do the same thing, copy this, and if I do the same thing over here, it is going to be int32 because all the values are integers. If I give one of the value as point, okay, I execute this over here, you see this also changes to float 64. You get the things right. Now if you look at this particular array, you and me, every one of us, you know that this is an array consisting of Mr. DJ Shiv SK. Hold on, let me complete with the topic. Don't be inquisitive in asking the questions. Okay, give me some time to explain. Did I conclude NumPy? No, right? Let me go ahead. Give me some time. I know what all questions can come from you all. Hold on, they will be addressed for sure. See, I was about to talk of the same thing and you immediately question the thing. So you got to wait for the right amount of time. Okay. So If you look over here, how many rows and how many columns are there? There are total 3 rows and 2 columns, right? So this is what is called as the dimensions of the array. Okay, and for checking the dimensions of an array, I have shape attribute. So I say print np dot shape, and oh, not np dot shape, rr dot shape. And you see over here, it is 3 rows and 2 columns. Simple as that. Okay. Now, if I do the same thing over here, we'll see something weird. Okay. So I'm not executing this. Let's keep it on hold. Let us come over here. Now, know over here that overall, you know it very well that this is a one-dimensional structure and this is a two-dimensional structure. So if I want to verify whether it's a one-dimensional or two-dimensional structure, I can use the attribute over here. So I can say over here print arr dot uh, not arr dot, I think np dot ndim. Yeah, that's a function of arr. So let us execute this over here and see. So it says that hey, it is a two-dimensional structure. In the same way, if I execute the same thing, tell me what is the dimension of this. We see over here that it is one-dimensional structure. Yes, no doubt it's a one-dimensional structure. Now, I will like to talk of the shapes over here. Okay, so what are shapes actually? Well, if I say what is the shape of this, well, you see the shape as 3 comma. So now you may say that, sir, but if you look at this particular array, I see over here that it has 1 row and 3 columns. So how can the shape be 3 comma? Ideally, it should be 1 comma 3, right? Well, the shape is going to be in the form of rows comma columns if and only if the data structure is two-dimensional in nature. If it is not in two-dimensional in nature, it is going to be always 3 comma. Endim stands for n dimensional. Endim stands for n dimensional. Okay, so endim over here, tell me the dimensions of this particular array. Now if I actually talk of this, now there's actually a bit confusion over here, and the worst part is my laptop has hanged. It's done. Okay, it happens sometimes. I don't know why. Anyways, but if you see over here, uh, arr.shape has given me the answer as 3 comma. You are expecting the answer to be 1 comma 3, right? If you really want the answer to be 1 comma 3, I will tell you what you got to do. First of all, if you want the answer to be 1 comma 3, you will have to ensure that it consists of 1 row and 3 column. That is, it should be a two-dimensional structure, and for it to be a two-dimensional structure, you have to declare it as a list of list, just like you did earlier. So now what am I saying over here is that hey, I want to create a two-dimensional structure because it's a list of list, and the first row of that is going to be 10, 20, 30. And what is the second row? No second row. No second row. Very much possible. So it is a list of lists. Now I can say that yes, it consists of 1 rows and 3 columns. Earlier it was not, but now it is consisting of 1 row and 3 columns. So this is 0, 1, and 2. Now if I copy these things, you will notice over here, if I do the same things for this, you will see over here that it is having the shape as 1 row and 3 columns, and it is two-dimensional in nature. You see, it's two-dimensional in nature. However, friends, this is not two-dimensional. It is just a single list. If it is a single list, this is one-dimensional. This is two-dimensional because I did give it in the form of list of list. Okay, and this over here is again in the form of 2D. So don't get confused with that. If it is a single list, make sure it is 1D array. Okay, now whenever it is 1D array, what is my numpy going to say? whenever it is numpy 1D array, numpy will say the output of arr dot shape. Look over here, output of arr dot shape is given as 3 comma. You know what does that mean? It simply means to say that, hey, in this one dimensional structure there are total of 3 values. That's it. Yes, it means in this one dimensional structure there are a total of 3 values out here. As simple as that. Okay, this is what exactly this indicates. Simple. So n dimensional is now clear to all of you. Now you know what? Perfect. One more thing, there are various functions of numpy. For example, if I say int np dot, now all the functions of numpy are available over here. See, so many functions of numpy are there. Should we know each and every of the functions? Absolutely not. Let's say one of the function is sum, and sum of arr. What are the values? In 20, 30. What is the sum of it? 60. Oh, yeah, perfect. I can do the same thing in two-dimensional arrays as well. But tell me, what is the sum of all of this? I mean, if you add this 1 plus 2 plus 3 plus 4 plus 5 plus 6, it comes out to 21, and that's correct. Okay. The same way, I can always say, instead of sum, I can always say mean. Instead of mean, I can always say median. Instead of this, I can always say minimum value. Instead of this, I can always say maximum values. Many functions are available. I'm just aggregating around the common things, and it will give us all the possible answers. Perfectly fine. Okay. So as you can see, mean is nothing but the average of the values. Median is the 50 percentile of the values. Minimum is the minimum of 10, 20, 30, and maximum is the maximum of 10, 20, 30. So that's working fine, right? I can do the same functions over here as well, and no doubt give me the answer in 2D structure as well. Okay. Now, you know what? I can also think of declaring a numpy array something like this. I'll show you. I'll just control A, control C over it and clear this off, and look over here. When numpy array, if they can store integer, if they can store float, you know what? They can also store a string. No doubt about that. They can also store a string. So let's say if I comment this and execute only the first part of it, you see over here that if one of the data type is string, everything gets converted to string. What does that mean? Well, it means that string has a higher precedence as compared to all other things, right? Whenever it was only integers, it was considered totally as int32. When one value became float, it converted everything to float 64. Why? Because float has higher precedence. When one of the values is converted to string, so when you have a combination of integer, float and string has the highest precedence. Therefore, you see over here everything is converted to string. Now you see the data type is u32. That's Python's way of representing string. It stands for Unicode character. Okay, it's again something like ASCII character representation. You need not get into the details of it at the moment. Okay, they are not required. If you wish to, you can just Google about it. Then how many values are there in this numpy array? There are total 4 values, and it's 1D structure. So when you look at the dimensions of it, it says that it is 1D. Perfect. Yes, sir. It's like Excel formulas. Now, after this, let me unwind the functions one by one. So I say over here, let me find the sum of this. Okay, guys, come on, tell me what is the sum of this numpy array. When I execute np.sum of array, I will like to know what is going to be the sum of the numpy array. Tell me very quickly, what is the sum of numpy arrays over here? What is the sum of this numpy array? 30, 40, 50, 60, right? So 60, 60.0. One is saying error, one is saying not defined, error 60.0. Well, let me try it. Okay, let us ask the computer only, hey, what is the sum of this? What is the addition of 10 plus 20 plus 30 plus darshan? It's a type error. Friends, please remember one very important thing. Although NumPy allows you to store all these stupid things inside it, but please don't store these things. You know why? Because if you remember our session, we start with the introduction to NumPy, where I said that NumPy stands for numerical Python. See, when you say numerical Python, what do you mean by that? It is used for performing calculation on numbers. So if you are using a string over here, although for storing it accepts, but it would be mere foolishness if you think of doing all these activities with NumPy. So never do it. NumPy is used for performing numerical Python. So usually when do we go for NumPy? When you have numbers. You don't go for NumPy when you have strings. Okay, most important thing. Okay, so don't do this. So we say, like, just to be on a safer side. Now, after this, the next thing which I want to talk of is 2D array is done. Then, yes, one important function. Precedence of complex, you have your Jupyter notebook. Try out. Okay. Complex is having lesser precedence than string, as far as I remember, but not very important, right? So if you want to find out, you can do it. But as far as my knowledge is concerned, as far as I remember, I think string has the highest precedence. You can check out on that thing. Clear to you, Ajay? Okay. Now, few more functions of NumPy. Mm, well, there is a function of NumPy is very important, but not right now, but certainly very important, and that is called as zeros. Okay, what is zeros function going to do? It says that just supply me with rows and columns 2 comma 4. So if you say np dot zeros of 2 comma 4, it is going to create a matrix of 2 rows and 4 columns and fill zeros everywhere. See over here. So you may say, what is the use of this function? I mean, it looks very much useless, right? I mean, why will I, you, me, anyone think of doing or creating a matrix of all zeros? Well, this is a very important function. When not today, not tomorrow, somewhere in machine learning and very prominently in deep learning, precisely when you work with the image data, at that time this zeros function is like our life savior. Okay, it is of that much importance over there. We are not applying it anywhere, but remember that it exists. Okay, so somewhere once in a while in your machine learning you may use it, but in deep learning it's required very extensively when you work on with images, somewhere during your CNN, ResNet, VGG architectures, not so early. Okay, yes, welcome, sorry, good to know. So next, just like this, we have once over here. If you do that, it is going to do the same thing but with all ones. Again, used in the same application as I just told you for zeros. That is ML deep learning image data. Okay. Now, if you are under the impression that just like zeros and ones, you have twos as well, that does not exist. So there is only np.zeros, np.ones. There is nothing which is called as np.twos over here. Makes sense, right? Okay. Uh, Next, Well, let me ask you, what are the properties of an identity matrix? What are the properties of an identity matrix? Let me hear it from you. What do you know about an identity matrix? What is an identity matrix? Let me hear it from you. What is identity matrix?
Sir, Kusuma is asking how to do the matrix multiplication.
I will take that thing later, therefore I ignored the question.
Okay,
Inquisitive
sir.
people. Uh, yes. What are the properties of identity matrix? Yes, come on, tell me very quickly. You remember? Don't Google out, just tell me. What are the properties of identity matrix? All diagonal elements are zero. Maite is saying a into I is equal to I into A is equal to A. Perfectly fine. All the elements are this. All the diagonal. One point I am missing. Just one point. I mean, all of you are right, but I'm looking for one point which I'm not seeing over here. Just one point. Uh, diagonal elements are zero. Diagonal one elements contain zero. That is fine. That is fine. Just one point. I mean, you all are very close. And if I disclose the point, you will say that, oh, we already knew it. Only one point. Usually, one of us does answer that. Ah, yes, Bhumika answered it. Square matrix always. Identity matrices are always square matrices. So if I say that, hey, I want to create an identity matrix of order 3, that means it will always be a square matrix like this with 1 1 1 over here and rest all zeros. Correct, right? So it's going to be a square matrix. I was expecting this point. All of you are right, no doubt, but I was expecting this point. Why? Because it is relevant to our function. Okay, so just like for creating a zeros matrix, you require rows and columns. Once matrix, you require rows and columns. If I have to create a identity matrix, I require rows and columns. So 2 comma 2, and it gives me an error. You know why? Because identity matrices are square matrices. So Python says there is no need to supply unnecessary things. Just tell me identity of 2. I will create an identity matrix of 2 cross 2. Okay. See, in spite of telling you all again, Nandakishore Kadam is saying me in array, why are we getting dots? Because that's the NumPy's default way of storing it. If you ask it, store it in the form of NumPy zeros or ones, it is programmed to get the value stored in the form of float. It prefers it. I mean, it's a more preferential data type because usually when you use numerical Python, most of the times you are going to get the numerical values, and that is the reason you have that 1.0 point. Okay, that's just a way of storing it. Getting that, Nand Kishore? Is that clear to you? Got it? Kalla ka tula? Whenever it comes to NumPy prefers to store it in this particular format. You or me can't change it. If you want to change it, yes, you can, but not required. I mean, it is not hampering us in any way. Perfect. Then how to remove the dot? You can change the data type, but not very important. That's what I'm saying, right? I mean, type is equal to C. Type is equal to, I told you, right? It's an attribute. But what have you gained after this, Mr. Mukesh? कोई फायदा नहीं हुआ, right? I mean, fine, we converted float to integer, but it is not considered. It is not even given any value. Okay, but you can do it if you want to, but not very much required. Getting that, Mukesh? You can do it, but not very much required. This is one way of doing it. Many other ways do exist. Okay, d type is equal to int. You can do that. Okay, then same with identity matrix. If I say, hey, I want to create an identity matrix of 5 rows and 5 columns, I can get it. Exactly, Krishna. Changing the data types, etc., and NumPy is irrelevant. That's exactly what I'm trying to explain you all. Okay, perfect. Now, there is a very important function. Well, we did go through NumPy, right? And this is how our NumPy actually looked at us. We had NumPy, and inside this, there were a lot of functions that we studied. One was NumPy's array function, one was NumPy's sum function. We studied mean function, we studied identity function, we studied zeros function, so on and so forth. You know, all of these are very generic functions, very common functions. Some of the functions are belonging to one of the type. For example, there is a module. Let me tell you, NumPy is itself a module. Module is nothing but a package. And inside NumPy, there exists a module which is called as random module, which has its own set of functions. One is called as rand, one is called as rand, and so on and so forth. I'm not going to get through all the functions. I just require one of the function out of it and to demonstrate the concept for you. Therefore, I am taking this. Now, if you want to access any of the NumPy functions, you write over here import numpy as np, and then you access everything by saying np dot np dot np dot np dot. If you want to access this function, let's say random, this is what I want to access. If you want to access random, you can't write np dot random, it's not available. Why? Because random is available inside random inside numpy. How do you write it? Np dot random, so that is going to go to np dot random, and then you can access this via this, which is random. Okay, remember this because it's altogether a different module. So now if I say over here that np dot random dot, so many functions are there, I'm using only one. I say over here 3 comma 4, you know what is that going to do? Let me store it as arr. It is going to generate me 3 rows and 4 columns. You see that? And all of the numbers will be centered around 0. All of the numbers would be centered around 0. What I mean by that is, if I say print arr, if I say print np dot min of arr, np dot max of arr, please observe over here, these numbers are centered around 0. That is the minimum value inside this. First of all, these are totally random numbers. Okay, these are totally random numbers, but these random numbers are generated in such a way that they are taken from a normal distribution. You may not know right now what is normal distribution, so let me keep it very simple. I would say that all of the numbers which are generated are more or less, not exactly, but more or less centered about 0. You see over here, the highest value over here is 1.12. Precisely, let us consider as 1.1. And the lowest value over here is minus 0.9. So you see, they are more or less centered around 0, right? Similarly, I mean, if I execute it once again, it will generate some other random numbers, and again you see they are more or less centered around 0. I won't say exactly. If it was exactly centered around 0, then the highest value would be plus 2.8 and the lowest value would be minus 2.8 or 2.18 in our case. More or less they are centered. See, so if I actually change the dimension, let's say I say I want 4 rows and 5 columns, or let's say 4 columns, say 6 rows and 4 columns. You see, more or less centered around 0. That's what I'm saying. If I say print this, I will not tell you the significance of this now because that will not make sense. Just understand that it is a useful function, so I'm taking it for a cause. Okay, it is certainly used in your machine learning applications. Now after this, Let me talk of indexing, right? I did not talk of indexing. Let us complete with the indexing stuff. Uh, so let's say we can do the indexing over here only. We need not look at any other cell. So I can just copy it from here and this thing also from here so that we can do that simultaneously. Not this one, not this one. Here. Okay. Now let's try to understand the very first one. What I will do is I'll add few more values over here, maybe comma 40, comma 50, comma 60. So we know how is this numpy array stored. 50 and 60 ARR. You can give any name, by the way. Sometimes people ask me, sir, is the name ARR compulsion? No, not at all. 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Now this is not at all difficult. You know why? Because numpy indexing is same as that of list indexing and tuple indexing. So if I say error of 0, you can see it has printed 10. So it's not new for us, right? Similarly, if I say print ARR of let's say 4, it's printing me 50. That's correct. Similarly, if I say print ARR of let's say minus 3, ARR of minus 3 in the diagram seems to be minus 40. So if I execute this, I get over here, yes, 40. Minus 3 is nothing but 40. Works fine. So then does my slicing also work over here? Well, okay, let us look at indexing only. For slicing, if I say I'm going to specify the rows over here, maybe I say get everything from this to this. That is right from start index 1 to end index. If you remember 4 minus 1. So it will get everything from index location 1 to index location 4 minus 1. That is right from here to here. This slice is being taken out. 20, 30, 40, you received it, right? You got it. It's exactly same. So I will not waste a lot of time over here. This is sorted. Now, I want to talk with respect to two-dimensional arrays. So when you create a two-dimensional array, something like this, we understand that we have over here uh, three rows and two columns. Values are 1 and 2, 3 and 4, 5 and 6. Okay, I told you over here this is row 0, row 1, row 2. This is column 0, column 1. And the indexing is always going to be in the form of row column. And if the name of this is ARR, the strategy for indexing is ARR of row comma column. Let us confirm that. So I say print ARR of let us say I want to access this 4 or let's say this 3, not 4, let's say 3. 3 is at row number 1 and column number 0. So let me write it. It's at row number 1 and column number 0. And yes, we get the number as 3. Similarly, sometime it works, sometime it doesn't. You can also write it like this, okay, row comma column. That's also valid. It gives me the same answer. So you can either access it like this, or you can always access it as R comma C. Both of them are valid ways of doing it. Whatever you wish to use that. Okay. So now this is what you get. In the same way, if I don't supply it, for example, I say print and I don't give this. If I say only ARR of 1, you know what? If you just say ARR of 1, that is, I'm saying that I want to access the entire row 1. I want to access the entire row 1. What is entire row 1? 3 and 4. So that's what you get, 3 and 4 altogether, right? So that is what we understand. Now, in this way, there are a lot more indexing, slicing operations available over here. We will talk of that later. Now let us move on to a new function of NumPy, which is very important, which is going to be our arange function. And you know what? Arange is very much similar to range in Python. What I mean by that? Well, friends, you know that in Python, I told you a couple of days back, range of 5 will generate numbers from 0 to 5 minus 1. Okay. If you are doing range function, well, NumPy says I have the same function, but I call it by arange. Okay. And if I say arange of this to this, I'm also going to generate for you exactly the same thing, but I am far more superior than this. Why? In terms of speed. Okay, let us compare that. And in the next session, I will show you this with the help of range and arange only. I will show you how NumPy is much faster than range function. So right now, let us use it. So I say over here np dot arange of, let's say, 5. Well, in Python, it doesn't work like this. We need to have a for loop. Remember, loop. NumPy says I don't require all that. I can do it like that. First advantage. Okay. So if I say range of 10, it generates number from 0 to 11. So you know what? Now it brings me to a question. If I store this, let's say, in an array which is called as x, and if I print x over here, this is what you get. Okay. Now, you know what? If I say print np dot and dim of x, it is a one-dimensional array, no doubt about that. And you see over here, the output is saying that I am one-dimensional. If I want to change the dimension of it, for example, listen to me very carefully. Whatever I say is very important for you to understand. How many values I have? Total of 12 values running from 0 to 11. So I say over here, these 12 values are ideally stored linearly. Let's say I want to store it in the form of 3 rows and 4 columns. Okay, so maybe something like this: 3 rows and 4 columns: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So perfectly they can be stored. So if I want to do something like this, can I do that? And it says that yes, why not? So I say over here, let me store it in y. I say x dot is a function of numpy, which is called as reshape. And I say I want to reshape it to 3 rows and 4 columns. No, not set, reshape. I want to reshape it to 3 rows and 4 columns. And I say over here, print y for me. Well, that's exactly what I wanted. Do you realize over here the dimensions are now 2D, right? It's a array of array. It's 2D. Not confirming? Wait a minute. I will do that to you. And of y. And you can see over here, this was the older structure, which is 1D. This is the latest structure, which is 2D. So we are confirm and sure over here. But you know what? Is one very important catch over here, and that catch is whatever you write over here, the multiplication of that should be equivalent to what you write over here. So 3 into 4 is equal to 12. That is the only reason you were able to do this thing, else you would not have been able to do that. For example, if I just copy this code again and I say, hey, it is going to be 4 rows and 4 columns for storing 12. Please observe, that's a value error. It's saying that it cannot reshape the array of size 12 to the shape 4 comma 4. And that's but obvious. How can you store 12 values in 16 locations? That's not possible. Okay, what if the values are less, maybe 4 rows and 2 columns? 4 twos are 8. 8 values have to be stored, oh sorry, 12 values have to be stored 8 locations. That's again not possible. So please ensure that if and only the multiplication matches, then only it's possible. Anything but multiplication should match. So if I say 12 comma 1, that is I am saying that hey, I want it to be converted to 12 rows and 1 column. Yes, 12 rows, 1 column. If I say hey, no, 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 I want to convert 1 row and 12 columns. Why not? It's a single row and 12 columns. Someone says no, 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 I want it to be 6 rows and 2 columns. So I say okay, 6 rows and 2 columns. You see over everything is possible. Anything which multiplies makes sense. You can also say over here, I mean, what more is there? 5 2 6 2, I mean, 4 3 is also done, 3 4 is also done. So let's say 2 rows and 6 columns. I mean, of course everything works provided the multiplication is the same. Okay, so what did I understand over here is that my 1D is converted to 2D. Now, yes, you can do that as well. Maiti, you can do that as well. Okay, now the next question which I want is 1D converted to 2D is done. What if I want to convert 1D to 3D? Well, that is also allowed. Say I have these 12 values. I simply say over here that hey, I want, let's say, you know, 2 comma 2 comma 3. You know what I mean over here? I'm saying to my numpy that I am interested in creating, I'm saying to my numpy, I am interested in creating how many arrays? Total number of 2 arrays. And of what dimensions? This is my row and this is my column. So please create for me 2 arrays of 2 rows and 3 columns. Create for me 2 arrays of 2 rows and 3 columns. Let us confirm. Has it created? Well, let us see. Uh, this is my 0th array. This is my first array. In this 0th array, this is at index location 0. This is at index location 1. This is 0, 1, 2. That is rows and columns. This is 0th row, first row, 0, 1, and 2. Right? So this is done. Okay, so let me just write it now. Okay, so what did I say? Hey, I want to create 2 arrays. Each of what dimension? What was that? 2 rows and 3 columns. Sorted. So 2 rows, 3 columns, 2 rows, 3 columns, and the values are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. To give a proper name to it, I say that this is my 0th array. This is my first array. Inside 0th array, this is the row and the column name. Inside first array, this is the row and the column names or numbers, whatever we say. Okay, now that's fine. Okay. Uh, yes, it's equivalent to a brick shape in 3D. 110% correct. Now, I like to go ahead with this. Okay, now where do I have it stored? Inside Y, right? So this entire thing is stored inside Y. So what if I say, okay, print for me Y? You know what it is going to do. So if I say print for me Y of 0, you know what is Y of 0 going to do? Y of 0 is going to print for you the 0th array, 0th array. And should be able to see over here that this is the 0th array which is being printed over here. Perfect. So if I want, I'll just introduce a small space in between. You see over here, this is the 0th array. Okay. I say over here, print for me in the, let's say print for me the first array. So I'm asking it to print for me the first array and this is what I get. Perfect. But I don't want that. Okay, let's say I want the first array's 0th row. I want this entire thing over here, this entire thing. So 0th row. So I say in this white array, I want the 0th row. First array, 0th row. And you get that 6, 7, 8. Now I say, no, 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 no. I don't want that either. I want this value specifically, only this value. So I say, in your array which you are calling it as y, I want you to access first of all the first array. Inside the first array, I want you to access the 0th row. Inside 0th row, I want you to access the second column. If you do that, you straight away get the number 8. So now let us do that and confirm it. Control V, and let's say, so yes, indexing done. You get this thing. Simple, right? Perfect. Now, but I'm yet to complete with this also. Okay, I'm just toggling around the topics. So as I told you, it is two arrays of 2 rows and 3 columns. Tell me what could be the other combinations which I can give over here. One which strikes me is 6 twos are 12. So I say 6 arrays, rows, 1 columns. Is this into this equal to 12? Yes. That means I want 6 arrays. Each array should be of 2 rows and 1 column. Let us confirm. Yes, I am getting total 6 arrays, and each array is 2 rows, 1 column. What all are the other possible things which you can think of over here? Tell me very quickly. Do you think other things you can do it over here? Come on, tell me very quickly. What all things when multiplied give you 12? 611. Okay, so 611 cannot give you 12, right? How can 6 comma 1 comma 1 give you 12? 6 into 1 is 6 only. The multiplication should turn out to 12. Mr. Classic Cartoon, 621. Okay, 1211 we can do. 341 we can do. So I say 12 comma 1 comma 1. We get this 12 arrays of 1 row and 1 column. So getting it, and it's a 3 dimension. Similarly, I can say over here 4 comma 3 comma 1, 4 rows, 3s are 12. Perfect. And you see 4 arrays of 3 rows and 1. Perfect. 2 comma 2 comma 3 is again a perfect thing. So 3 threes are 9. Pooja, how can 3 comma 3 comma 4 be there? 3 threes are 9, 9 fours are 36. Not allowed. Not allowed, Pooja. Wrong, 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 wrong. 3 comma 3 comma 4 is wrong. Multiplication of this value should turn out to 12. Okay. 3 threes are 9, 9 fours are 36. That's not allowed. Cool. So you get this thing, right? So now let me ask you one more question before I proceed. And that another question is, if you remember, I told you one important thing, that in your NumPy, we are going to talk of two things. One is going to be the n dimension ND array. One is going to be the ND array. And what is the second one? Do you remember? Let me see how many of you are very much attentive in the session. It consists of ND array. And what is the second one? Full form of that. Can you tell me full form of that? I'm sure you will be able to tell. Form of that. Can you tell me? You fat? Not you fat, but yes, I mean that's good that you remember it. It's U functions, U functions, and the full form of that was universal functions. Correct, correct, Abdul. So we have to talk now of the next part of it, which is called as universal functions. Okay, so not vector, universal functions. So I say, okay, universal functions, that is U. Okay, so now uh, let me create an simple numpy array. So I say shortcut p dot a range of 15 values, and now I say please reshape it to 3 rows and 5 columns. RR. Well, I did not say that this is U functions. No, this is what we studied, 3 rows and 5 columns. You know what? If I say what is ARR plus, let's say 10. If I say ARR plus 10, point number one, we should understand that when can two arrays be added? Jayatirtha, yes, you can do the slicing in 2D and 3D array as well in the same fashion. It will not change. Okay, row, column. That is how you do it. Okay, so that can be done. We will talk of that also in some time. So first of all, you can't add over here, right? How can you add 10 to this if the dimension of first array is 2 rows 2 columns? If the dimension of second array is also 2 rows and 2 columns, then only you say that a plus b can be added to give you a third array of 2 rows and 2 columns, right? But over here, surprisingly, when you execute this to get an error, no, you don't get it. In fact, it's added. You know why? That is because of universal functions. You know why? Because universal functions support a concept of broadcasting. So, what is this concept of broadcasting? Well, this concept says that if you say that I'm going to add with this, NumPy automatically broadcast 10. So, what is the dimension of this? 3 rows and 5 columns, right? It will broadcast 10 for 3 rows and 5 columns. So, 3 rows, 5 columns, and it will ensure that it fills 10 everywhere over here. And now every value can be added, every value can be added over here, right? That is what is the advantage that you get over here. So you see 0 to 14, everything is added with 10. It goes from 10 to 24. That is called as the broadcasting feature of NumPy. Okay, now if that is the case, I would like to talk of some other. Uh, and let's say I'm going to create few arrays over here. Let's say my array number one is np dot a range of, let's say, 15, and I'm straight away going to reshape it on a single line. Okay, that's very much possible. 5 comma 3, and np dot a range of, let us say, 5. Many students get confused over here, so please pay 100% attention. 5 comma 1, and I say for me arr1, for me arr2, and then say what is arr1 plus arr2. First and foremost thing, okay, if I comment out this line and if I try to execute this, what do you see? The first matrix is of dimension 5 rows and 3 columns. The second matrix is of dimension 5 rows and 1 columns. How can 5 comma 3 be added with 5 comma 1? It just can't be added, right? It can't be added. Now what is going to happen? This is our first matrix, calling it as ARR1, having the dimensions 5 rows and 3 columns. This is our second matrix, right? Let me write it over here. 0, 1, 2, 3, 4. What is the shape of this 5 rows and 1 columns? Obviously, I know that if I want to add matrices, the second matrix should also be of the same size. Then only the resultant output can be 5 cross 3, which is not allowed over here. So obviously this is to give me an error. But NumPy says I have the funda of broadcasting. The same number can be repeated multiple number of times, or the same array can be repeated multiple number of times to suit the dimension of other array. That is, now I understand over here the shape is 5 rows and 1 columns. Okay, I say I can replicate this array once more. Now it becomes 5 rows and 2 columns. I say I can replicate this array once more. 0, 1, 2, 3, 4. Friends, now if I look at this particular array, it has become 5 rows and 3 columns, and now this is actually my array 2, and now I can add this. So when you add it, what is going to happen? Well, corresponding values are going to be added and the output is going to be 5 cross 3. So 0 is added with 0, 1 is added with 0, 2 is added with 0, then 3, 4, 5 each added with 1, 1, 1. So 3 will become 4, 4 will become 5, 5 will become 6, 6, 7, 8. Each of them added with 2, 2, 2. So 6 will become 8, this will become 9, and this will become 10. 9, 10, 11 added with 3, 3 is 3. So 9 plus 3 is 12, this is 13, and this is 14. And each number would be added with 4. So this is going to become 16, this is going to become 17, and this is going to become 18. So addition successfully done. Okay, are you all able to follow it? So this is the expected output of this is the expected output. Let us confirm, are we getting the same output? And oh, we did not even uncomment this. Compare your output, this output, with what you got. It is allowed. Point number one. Point number two, now you may say that, okay, so can I add any matrix of any size with anything? No, there should be at least one common parameter. At least in this case, when you see, right, this and this matches, so broadcasting can be done over here, right? 5 and 5 matches, therefore this one can be broadcasted to 3. If it doesn't match, then sorry, it's not done. Okay, perfect. So okay, cool, everyone got this, very nice. This is called as universal functions. They support the concept of broadcasting over here. Okay, now coming on to your question, right? Some of you are very curious. So let's address that question because now it's the right time. The matrix multiplication, right? Yes, at least the rows or columns should match. Correct, Krishna. So Krishanu, correct. Uh, G test, I think. Acha, great. Probably that means great. Okay. So let me uh, two arrays. So I say numpy array, and I'm going to create it in the form of 2D arrays. So let's say uh, first row consists of, yes, it is only limited to numpy 1, 2, 3. Second is, let's say, 4, 5, 6, and the third is, let's say, 7, 8, 9. Similarly, I'm going to create another numpy array which is going to be equal to numpy dot array. It is a list of lists. Let's say the first value be 2 comma 2 comma 2 comma third be, next be, just to keep it very simple and fast. Done. So I can say over here int a, int b, and execute. So yes, these are the two arrays. Now if I want to perform matrix multiplication, well, my matrix multiplication is performed by using the dot function. Okay, it is performed by using the dot function over here. So I can say over here a dot b, and you get the answer for this. You can verify the answer later on, but that's how you perform the matrix multiplication. Okay, uh, Sarit Verma, this is this only limited to numpy, the addition of the matrix slash, I mean, uh, no, you can also do it for multiplication. See, unless and until the matrices match, addition, subtraction can be done. But multiplication, for that, rows and columns should match. Okay, it will not do matrix multiplication if it is not matching, because else it will generate erroneous result and doesn't make any sense. So yes, the next one which I want to talk of is the Transpose of a matrix. Transpose is rows and columns interchanged. So if I consider this as one of the matrix and I say print A, if you want to print the transpose of it, it is just an attribute which is known as T and it's sorted. So you say A dot T, you see the rows and the columns 1, 2, 3 have swapped their positions, 4, 5, 6 have swapped their positions, and 7, 8, 9 has also swapped their positions. As simple as that. Okay, cool. So, okay. Now, after this, the next thing which I want to talk of is, let us say, solving. Okay, solving linear algebra problems. Let us say I want to solve linear equations. I want to solve linear equations. So what I say over here is, let's say I have some linear equations for solving. Maybe I have 7x plus 5y minus 3z is equal. Look over here. This is very cool thing. Okay. Then I say 3x minus 5y plus 2z equal to minus 8. Then I have 5x plus 3y minus 7z equal to 0. Okay. Uh, we have all solved such type of problems when we were in schools, right? Schools, colleges, solving this linear equation was something which is considered as a 5 mark problem in your schools, right? Now, let's ask Python to solve it for us. So for that, Python, just like it had NumPy, just like it had a random submodule, in the same way, there is a submodule which is called as linear algebra. Okay, so what happens over here is, let's say, what am I going to do now? I'm going to put up all these values into one matrix. Let me call it as A, and I'm going to put up all these values into another matrix which is called as B. And then I'm simply going to give a call to the linear algebras solve method where I will say, hey, please solve for A and B. So we know that it is going to give me three possible values. We want the value of X, we want the value of Y, and we want the value of Z. Let us see how to give it. Well, what we say over here is, let my AB is equal to np dot array of, what is the first row? First row is 7 5 minus 3. So let me write it over here, 7 comma 5 comma minus 3. Cool. What is the second row? 3 minus 5 2. So I write over here 3 comma minus 5 comma. And what is the third row over here? 5 3 minus 7. So I write over here 5 comma 3 comma minus 7. Sort. Now then I say my b is going to be is equal to numpy dot array, and this is again going to be a array of array. No, it's just three values, right? 16 minus 8 0. So I write it as 16 comma minus 8 comma 0. So my a and b are solved. So I say, what are going to be my answer? So I say answer is going to be, I'm going to simply call the linear algebra submodule. Inside that I have the solve method, and I simply solve for a and b. And you know what, the moment I say print the answer, I'm going to get the answer of x, y, and z. So these are the best values. You can try solving it manually, you will be getting the same answer, that's a guarantee. So that's how easy it is to solve linear equations using NumPy. So by now you understand it, right? NumPy is used for performing numerical operations, not the string operations. Therefore, If you want to play around with numbers, go with NumPy. Else, ignore that. As simple as that. Okay. Wow. If we had Python in our school days, it would have been a cakewalk to solve the equations. Wow. 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 Very nice. Very nice. I, cool. So this is where I would say that we have come to end of NumPy, and now we start with matplotlib library. Okay, end of NumPy and starting with matplotlib. So if you have any questions related to NumPy, please feel free to ask me at this point of time. Any questions you feel that you didn't get in NumPy, feel free to ask. But see, many of the things are very readily available in NumPy. If you want, you can just go to the NumPy documentation and access those functions. See, I told you how to use most of the things. Rest all, of course, there are many things over here. That's exactly what is getting covered in the advanced courses. Okay, level 1 is done, level 2 and level 3, right? Level 1, level 2, where all those things I think are covered over here. This is essential, so therefore we are just aiming to give you a good essence of what all things are required for data science. So if you have any questions, feel free to ask me at this point of time. You are most welcome. Else, we will go ahead with the next one, which is called as matplotlib.
Guys, for a reminder, just put your attendance for the today. It's compulsory for being eligible for the exam, and the exam is on Sunday. So if you have any queries, any doubt till now, you can ask.
Yes, Sarit,
Yeah. Sir,
NumPy. Yes, yes, Jyotsna.
yes, sir, I was taking for the surrey out and you are reading that.
No worries, I'll take it.
Yeah.
Naresh is saying no questions. Can you do trigonometry? Yes, you can certainly do that. In fact, we do cover trigonometry operations in the level 1, level 2 courses. Please explain 3D shape again. Do we use only reshape function? Reshape is just one way of doing it. There are other functions available, but reshape is very much popular. Okay. NumPy can be used for doing trigonometry operations, Nankishore, certainly. Okay. And regarding this 3D shape, I would suggest Sarit to once again watch the videos, because practically explaining that once again is going to take us a hell lot of time. Okay. That is already explained very nicely, slowly and steadily. So I'm sure if you just revisit that small part of the video, 110% sure you'll get it. If you still don't get it, feel free to ask me in tomorrow's session. I will ensure that I explain that to you once again. Okay, that is for sure. Oh, Siva, don't thank me for the wonderful class. We are yet to continue. I told you today we are going to have a session of 2 hours. So thanking at 8:30, not before that. Okay. So can we use NumPy for integration for third order and solving the limit problem? I never use that, Rahul, to be very honest. So I need to check. Not very sure. But I guess yes. Where do we use where do we use linear algebra? Where do we use linear algebra? I mean, what kind of question is this, Mr. Cartoon? Linear algebra, we have used it since our school days, right? Then today is my first time in the class. Fantastic explanation. What is the exam date for on Sunday? I don't know. Josna, please take that question later on, not
Yeah.
right now. Rahul is saying, sir, I'm not feeling confident in Python. Any suggestions how to go practicing about it? Well, the only key to practice is you should have your keyboard in hand, think of the problems and try to solve it on your own. Okay, unless and until you practice, see, you have to understand, Rahul, any programming language is like maths. Okay, and how do you get more and more confident in mathematics? By practicing, right? And the same thing comes to programming languages as well. Go to websites like hackerer.com, hackerrank.com, uh, this freshersworld.com. You get a lot of problems. Start practicing over there, start accepting the challenges which are available over there, build your profile over there, solve the challenging problems, and this is how your skills will get developed more and more. So that's how you can think of tackling that particular thing, Rahul. Okay. Yes, Jyotsna, you are done now. The
Yeah.
exam related questions.
Yeah, exam is on Sunday, and you will, if you are registered at the www.letsupgrade.in for the program, you will get the link for the exam on your email, and from there you can take the test.
Okay, let's go ahead then, starting with matplotlib. Well, when it comes to matplotlib, we don't require matplotlib entire functionality. Matplotlib is a library which is used for plotting. Yes, you can plot 2D and 3D plots as well, but our main focus in essentials will be on 2D only. I'll not talk of 3D. We usually talk it in the advanced courses, not right now. So if you want to import matplotlib, well, you need to write over here import matplotlib. Well, inside that you have dot iplot as plt. Okay, you need to import it like that. Okay, now, well, matplotlib is something which is considered as an alternative for MATLAB. Okay, earlier researchers used to code in MATLAB because coding in MATLAB is very easy as compared to any other programming language like C, C++ for visualizing the things. But again, the problem with the MATLAB is you need to buy that. It's not free. Today, Python being open source has replaced MATLAB, and everyone, be it EXTC engineer, biotech engineer, for doing the genome analysis, for doing their circuit works, for doing any kind of signal processing applications or image processing applications or digital signals, they go with Matplotlib. Okay, now, to be very honest, Matplotlib is something which has become a bit clumsy over time. It is old fashioned, but again, you have to understand that it's one of the most basic library and yet useful as of now. So that is the reason we are starting with Matplotlib. In fact, why we? Anyone always starts with Matplotlib before going ahead with anything else. So that's how we have it, right? Now, over here, I can set different styles in Matplotlib. So if I say plt dot style dot use, and I say uh, over here, one of the style which is there is called as classic. Now you may not understand what is this. Well, let me show you what I mean by that. Just go to Google and I say Matplotlib style gallery. Going to the very first link. You can go to any link. Well, if you remember, I have used style. Now, friends, please observe. If you observe over here, this entire thing has the same plots, not even an inch here and there. This also has the same plots. This also has the same plots. The only thing is the same plots are shown in different themes. Yes, different themes. Look over here. This theme is BMH. Let's look at it. This is BMH. The same plots in classic look like this. The same plots in dark background look like this. Similarly, bar plots in BMH, dark plots in classic, and bar plots in dark background. So whatever you like, I mean, see, it's all about ultimately what feels more soothing to your eyes. So some people like dark theme, so they can use the style as dark background. I'm using the style as classic so that the things are very easily visible to all of you. The same way, there are a few more things. 538 is another style. ggplot is another style. Grayscale, Seaborn Bright, Seaborn Colorblind. Yes, for colorblind people. So now I can take that also. Then Simon Dark, Simon Dark palette, and so on and so forth. So many types of styles are there. Doesn't make sense to discuss all. So if I say over here, I'll just share this link with you so that it will be easy for you as well. So this is the style which I have set. Okay. Now, cool. Let us plot our very first diagram, and that is going to be, let us say I am interested in plotting the sine wave. I'm interested in plotting the sine wave. How do I plot it? See, plotting can be done by using the plot function of matplotlib. Okay, plot function says give me the x-axis value, give me the y-axis value, and I will plot for you. So matplotlib is available in plt, right? So you need to write over here plt.plot x and y. So you need to give x and y over here. So I say I need to create my x first. So what will I do over here is I say x is equal to numpys. I'm using the numpys sub package which is called as line space. So that also gets covered, right? Line space. And I say over here 0, comma 10, comma 100. I say x. What does that do? Not very clear, right? So I'll do everything. 0.10 comma 10. You know what does this do? Well, it divides the range in between 0 and 10 into 10 equivalent graphs or 10 equivalent ranges. I would say 10 uniform ranges. Try subtracting 1.11 minus 0. The answer is 1.1111. Try subtracting 2.22 minus 1.11. The answer is 1.111. Try subtracting this minus this. The answer is this. Try subtracting this minus this, or this minus this, or this minus this, or this minus this, or this minus this. Everywhere the answer has to be 1.11. This is exactly what my line space does. It is going to divide the numbers in 10 equal buckets. It is going to divide the number in 10 equal buckets. So you can try out with anything else. So if I say, hey, I want to try out with, can you think of dividing this into 5 buckets? Yes, why not? So you can see over here, difference between each of this is 2.5. This minus this 2.5. This minus this 2.5. This minus this 2.5. Similarly, if I say, hey, please divide it into 100 equivalent buckets, you can try this. They are uniformly spaced. Okay, so you get this thing. Now after this, I say over here that x is clear. Okay, so many x's are generated. Now what am I going to do is I have generated x. Now what is going to be my y? Well, let's say if this is x, my y is going to be, I'm going to use the numpy's, let's say sine wave, sine of x. So what is sine of 0, sine of 0.10111, sine of 0.20222, so on and so forth for all of these 100 values. So this is my x and that is my y. That's now making sense. So precisely I say I want to plot x which I have obtained over here versus y which I have obtained over here. Let us do that. So I say my x is ready. Yes. So what is my y? My y is np dot sine of x. Both are ready. Now what to do? plt dot plot x comma y. Execute that. What you get is a sine wave, right? That's exactly what I told. What you get over here is a sine wave. I can put you see over here, this is something which is unnecessary troubling us. Well, it says that this particular figure is saved at this particular address in the memory. The id operator, I hope you remember. But I don't want to see all these things. Put a semicolon at the end and you'll see that's suppressed now. So that's a good practice to have a semicolon at the end. We don't anyways understand anything from the object address. So that's how it is being used. Okay, that is our sign of x. Okay, now what if I want cos of x as well? So let's say z is equal to np dot cos of x. I say let me use the plot function over here. Lt dot plot x versus z. But if you realize over here that I am doing the same thing over here in the same cell. If I do it, see how smart is Matplotlib. It creates two lines. One is for sine, one is for cos, one which is there in blue, which is for sine, and the one which has come over here, it is for the cos. So you understand over here, both of these do make a significant impact. We understand that, right? So that makes sense over here. Now, there is one important thing which I want to talk of, and that is the thing which is called as percent matplotlib inline. Okay, percent matplotlib. Tell you what it is. Like, let me tell you. By default, it is always inline. That is, I use this along with percent matplotlib inline, which is anyways the same. So, uh, yes, unrecognized arguments. I think I should take it out in a different cell then. By default, it's always inline. Yeah, that's fine. Okay, we can't add comment over here. This is what it is saying. Okay, or I can say over here, somewhere on the next line is fine. Yes, and if I paste it over here, okay, done. If I execute this, well, you observe this output and you observe this output. They are one and the same. Absolute, not even a millimeter here and there. This output and this output is one and the same. Okay, but you know what? I want to show you something new, which is something which is not by default, and that is called as person matplotlib notebook. Now what is notebook going to do? Well, notebook is going to make this plot a bit interactive. How? Well, if I execute this particular plot, first and foremost you see the display. Okay, this display and what is available over here versus what is available over here. I'll just reduce it. Yes, there's a difference. If I hover over here, you please observe over here the x and y values do come, right? So that's much interactive, right? Then I can also use the left and right buttons to control my x and y axis. So I can just scroll it up and down wherever I wish to, and I get the answers. Then this is for zooming in. So let's say I want to zoom this particular part. Oh, zoom it and look at the values. I want to zoom this particular part, zoom it and look at the values. If you want to save that, you can download it. And why is it not coming? Download it. Ideally, it has to. Quite surprising. Why is it not coming? But it has to. And when I click this, it is going to stop the interaction. Done. So I execute it once again. And now if I click on download, don't know what is the problem. Maybe my cookies are blocking it, something like that. Probably. But you understand, right? But I would prefer to use person matplotlib inline only. Okay, I'm not going to use anything other than that. But if you want, you can use something else as well, notebook also, but I will prefer inline. uh, Aryan, I am really unhappy with the fact that the course is not covering ML. What when it's being marketed as essentials in data science. So Aryan, then I think you are at the wrong place because you are unnecessarily disconnecting all of us from the subject. You know why? Aryan, you should have gone through the website to look at the curriculum before commenting anything over here. Okay, so please go through the curriculum, look over here what is there in the curriculum, what is in the essentials of data science. We are not offering anything which is related to machine learning over here. Okay, visit the curriculum, see what are the contents, and then comment rather than coming up all of a sudden and commenting anything. So wish you all the best, Aryan. Okay, let's go ahead now. uh, where was I? This and this notebook and matplotlib is done, then default is also clear to us. Okay, let us look at some other ways of plotting the things. So I say, okay, let my x be equal to, although I have my x ready, but let's say if I write x is equal to np dot line space 0 comma 10 comma 100, and then I say plt dot plot x comma np dot sine of x. I can do it over here itself, and you know what, I can also give the third parameter over here saying hyphen. What do you mean by that? Well, by this hyphen I mean that I am interested in having a solid line. So when I execute this, difference identified, right? So give me a few more seconds, and I say over here, this time I want you to not plot a sine, a cos, and the style of the line which I want is dashed line. Okay, so when you supply it as this, it means I want a solid line, and when you supply it like this, I mean I want a dashed line. Let us look over here. As I told you, it's put a semicolon for better purpose and done. And if you see over here, now you understand the difference, right? By default, anyways, it's a solid line. We know it, right? This is for the dash line. You get to see that yes, these are the different ways in you can do it. Now a very important thing which I want to talk of over here is going to be, I don't like to see these plots one over the other. I mean, okay, if I say, hey, this is what is the plot available for us, can you please tell me which wave is a sine wave? So am I going to once again sit with a calculator and see whether blue is a sine wave or the dashed line is a sine wave? Obviously not, right? I can't do that over here for a very obvious reason. So what to do in this particular case? The simplest solution to that is going to be plotted on different axes. That is, I say over here that I say, if I request a graph paper in my exam from my supervisor, I will say that I have two questions in the question paper wherein I want the graph to be plotted. Therefore, I am going to divide this into two parts. So, how many parts are being divided? Well, I see over here that I have divided into two rows and one column. So we see over here that there are two rows and one columns. So this is going to be the first part of it, and this is going to be the second part of it. Okay, I have divided into two parts. Or I could have also divided it into something like this. Okay, where I say I want one row and two column, where this is the first part and this is the second part. But let me first talk of this scenario, then I will talk of this scenario. Okay, so what do we do over here? Now, if you want to do this, as I told you, we are going to initially request the supervisor, can you please give us the graph paper, right? So because we want to plot, right? So I say over here, for that, I need to say, hey, plt dot figure. Okay. Then I say plt dot plot, and I say over here, 2 comma 1. No worries, Aryan. That's fine. That's fine. Okay. No problem. Thank you very much. See, Aryan, machine learning is something which is advanced and we don't offer it free, or rather, to be specific, rather than saying we LU or no one will offer it free. So that is covered in the advanced courses. This is data science. Machine learning is altogether a different batch which is getting covered in our AI ML courses. Okay, that is where machine learning would be covered in and out, not in this. Okay, so that's how it is. No worries. So I say over here 2 comma 1 comma 1. What do I mean over here is, hey, I want you to create two subplots. Okay, I want you to create two subplots. Sorry, not two subplots. I want you to divide this paper into two rows and one columns. So as you can see, two rows and one columns. And currently I am talking of the first part of it. So I say over here, I want you to dot over here versus, let's say, sine of x, and then I say lt dot subplot 2 comma 1 comma 2. That means I say that, hey, this paper is divided into two rows and one columns. Right now I'm talking of the second part, that is this. So this is where my sine will be plotted and this is where I'm going to plot my cos. So I say over here lt dot x versus np dot cos of x and sort it. Now if you see, it is being divided into two parts. If you want that solid line and all things over there, you can always have it. uh, and this is where it comes. Now this has divided into two rows and one columns. If I want to divide it into one rows and two columns, can I do that? Yes, why not? So if you want it to be divided into one rows and two columns, please ensure that you write the same thing over here as well. So that's going to be one rows and two columns, and that's sorted. And you see over here I have divided it into one rows and two columns. Now one important thing or one bad thing, I don't understand what should I say over here, but I can also control the size over here. plt dot figure, and inside this we have fixed size. Fixed size is equal to, let's say, uh, 15 comma 5. And if you execute this, you see over here that it is now stretched. Now you may ask, sir, what is 15 and what is 5? Honestly speaking, till that I never researched on it, to be very honest. Okay, so 15 and 5, probably they are the screen size in inches. 15 inches by 5 inches, probably something like that. Not very sure on that, but this is how it is. uh, I'll try changing it. So if I say uh, let's say 10 comma 5. If I say 10 comma 5 and I execute that, you can see the difference, right? The width has changed. So 5 is still too large, so I say 10 comma, let's say 3. And you see over here makes sense. And similarly, if I want, I can set the size over here as well. So I can say over here fixed size is equal to, this time giving 10 comma 3 will not make sense. I should give larger in width. So I would say width is fine, I can keep it to 3 as well, but the height should be this. So if I say over here comma 3, no, ideally it should be, 4 comma, let's say 15. That's too much. That's too much. So let me give it as 4 comma 8. Yeah, makes sense, right? And if you think this 4 is also too large, you can give over here 3. You get it. So I think 3, that should be this. 3, no, that should be ideally 5. That makes sense. And plot wise, if you want to reduce that, you can do this. So we can, sir, can we label two figures in can we, yes, we can do it. I will talk of that in the tomorrow session, wherein I'll be continuing with the matplotlib. We can do that, right now the basics, Sarit, and then we are going to go inside this. Okay, I think Divyendu has googled about it. Width and height in inches. So my guess was right. It is width and the height in inches. Help of PLT dot figure. Okay, that's very nice. So good. So along with you, I am able to help us out. So help of, let's say, PLT dot figure, and you can see over here it says figure fixed size. It is in inches. So yes, so perfect. So what I said was kind of right only, right? It is nothing but it is in inches. Cool. Thank you very much, Divyendu. That's perfect. So cool. All sorted. Any questions so far? Or we can call it a day.
Guys, if you have any questions till now, you can ask. So let's end for the session today, sir.
Perfect. Perfect. Thank you very much, guys. Have a good day. Bye
Thank
bye.
you.
Bye,
Thank you,
Jyotsna. Thank
guys.
you very much.
Just don't forget to fill the attendance form. Thank you. So let's call for the session today. Bye bye, guys.
Thank you, sir. Thank you, Joshna.
Thank you.
Thank you, Jyotsna. Bye bye.
Bye bye, sir. Good night, sir.